All right, this is a solution to 2.4, number 45. Just a pretty large-looking application problem about a chain falling off a platform. And most of this problem is actually just just words in a background. They actually give you the equation for this from the get-go. But still, I'm going to kind of describe a few pieces of this. So, portion of a uniform chain of length 8 feet. So that means that this chain here is 8 feet long total, okay? But a portion of that chain is hanging over. Let's see. Suppose that the length of the overhanging chain is 3 feet, and that the chain weighs 2 pounds per feet. Both of these pieces of information actually are extraneous, but I'm just going to say the length of that chain at time 0 is 3, and then what is it? 2 pounds per foot, but that doesn't actually matter. And that the positive direction is downward, starting at time equals 0 seconds. The weight of the overhanging portion causes the chain on the table to uncoil smoothly and fall to the floor. Let x of t denote the length of the chain overhanging the table at any given time. That's why I said x of 0 is 3, because there's 3 feet initially hanging over. Then v, which is dx dt, is the velocity of the chain, the falling chain. And it will be positive, by the way, because downward is positive here. When all resistive forces are ignored, so friction and air resistance are ignored here, it can be shown that a mathematical model relating v to x, this is the velocity to the length of the chain, is given by the following differential equation. So all of that wording was really just to set up, hey, guess what? This is a differential equation that dominates this situation. Rewrite this in differential form. So part A is just first asking us to rewrite this in differential form. I'll just slide off to the side and write this as xv dv plus, I'm going to move that 32x to the left-hand side. So I'll get v squared minus 32x and then dx. Now remember, x is denoting the length of the chain that's off of the table. V is its velocity. X is a function of time. And so therefore, through composition, v is also a function of time. But in this case, we're really considering v as a function of x, as a function of length. Anyhow, I don't want to read problems 31 through 36. I'm just going to solve this DE. Okay, so solve this DE. Find an explicit solution, v of x. Great. So what I'm going to do, I'll use a different pen color here. I'll call this bit right here capital V. I'll call this bit right here capital X. Now let's hope that this is exact. It is not, by the way, if you were to look at the original equation. It's definitely not linear. It's definitely not separable. So that is, those options are out. So the next option would be either a substitution or using some type of exact method. So let's look at v sub x. V sub x, the derivative, partial derivative of capital V with respect to x, is going to be little v. Remember, little x is considered to be a variable there, but little v is not. And then x, capital X sub v, derivative of that capital X function with respect to v is going to be 2v. Well, these are not equal. So that means this is not exact. So what do? We multiply both sides of that equation by a mu. And I will go ahead and write that in. I have mu xv dv plus mu v squared minus 32x dx is equal to mu times 0, which is just 0. And now we want this mu so that this is now exact. So we want, I'm going to call this now maybe I'll call this capital V bar, and I'll call this capital X bar, all right? And I want capital V bar sub X to equal capital X bar sub V. That's what we want. We want to force exactness. So to be exact, this would have to be true. Well, capital V bar is capital V bar sub x, the partial of capital V bar with respect to x. Well, I'm going to treat mu as its own function, and I'm going to treat xv as its own function. In other words, when I take the partial with respect to x, I'll get mu sub x times xv plus mu times xv sub x. And I want that to equal, again, take the partial of capital X bar with respect to v. I'll get mu sub v times v squared minus 32x plus mu times the partial of that with respect to v. So the partial of v squared minus 32x with respect to v. We have already found what those partials are. The partial of xv with respect to x is right here. The partial of the v squared minus 32x with respect to v is right here. So we don't have to actually think to do those two. So here we go. I'm just going to write this in. I should continue with blue though. Mu sub x, xv, plus that's going to be mu times v should equal mu sub v times, again, quantity v squared minus 32x plus mu times the partial of that, which is going to be 2v. So I'll write it as 2uv. Now we're going to have to make an assumption. Is mu a function of v or is mu a function of x? I will probably prefer mu to be a function of x, just so that this ugliness, let me highlight it, this ugliness disappears. If I suppose mu is a function of x, then mu sub v will be 0, and that'll disappear. So I'm going to go ahead and suppose that mu is actually just a function of x, which will imply mu sub v is equal to 0. So if I do that, then mu sub x is actually just the derivative of mu with respect to x, so total derivative times xv plus mu v should equal, now remember mu sub v is gone, it's 0, so it's just equal to 2 mu v. I'll subtract mu v from both sides, so this implies d mu dx is equal to, I'll just say it's equal to, is equal to mu v over xv, which is the same thing as mu over x. And if you take a look at that, the left-hand side is a function, the derivative of mu with respect to x. The right-hand side only involves mu's and x's, so this is totally separable. Well, that's not why it's separable, but this is now, we can now work with this, and it is separable. This will imply 1 over mu, d mu, is equal to 1 over x dx. And if you do a little bit of work there, this will imply that mu must therefore equal x. That shouldn't be too terribly difficult to see because it's 1 over mu, d mu is equal to 1 over x dx. They have to be the same function, or at least off by constants. And remember, technically speaking, mu is actually a constant times x, but because we're multiplying every single term of our original dE, let's get right here, by mu, then we can assume, let me highlight this guy, we can assume then that the coefficient of mu is just a 1. Okay? So let's go ahead and actually take that differential equation that's in differential form and substitute x for mu. So I'll go ahead and rewrite that off to the side here. That'll give us an x squared v dv plus x times v squared minus 32x dx will equal 0. Now, remember, we're trying to solve this. This I know is going to be exact. So this business here is going to be f sub x, and this business right here is going to be f sub v. Okay? So, oops, I wrote that backwards. Sorry about that. That's f sub v, and that's f sub x. Sorry about that. Okay, so choose one of them to integrate, and the other one we're going to try to match. So I'm going to actually choose f sub v to integrate. This bad boy right here. So let's see. My f of xv, vx, actually I'll write it that way, f of vx should be the partial integral of x squared v with respect to v. That's just f sub v. And when you integrate that with respect to v, you'll get x squared v squared over 2 plus some constant. Now, a constant could be a constant, actually, but when you're taking a partial integral like this, the constant that will pop out could be a function of x. All right, so let's see. That's my actual function. Now, I've used the f sub v. Now I'm going to go ahead and take the derivative of that function and compare it to my f sub x, which is this guy right up here. So let's go ahead and take the derivative of that function, f sub x, of this function right here. That'll give me, let's see, an x v squared plus a g prime of x. And we're going to compare that to, again, I'm just going to wiggle the highlighter on it, but again, we're going to compare it to that f sub x up there. So we want, I'll write it in blue, we want that to be, I'll distribute the x v squared minus 32 x squared, and you can see what g prime is going to be. G prime has to be the negative 32 x squared. So let's go ahead and find out what g is. So that implies g prime of x is a negative 32 x squared, which implies that g of x, after you do an integration there, is negative 32 thirds x cubed, technically plus a c. However, remember when you solve an equation that is exact, your solution is going to be f of x v, or vx, actually maybe I should put it in alphabetical order. Your solution should be f of vx is equal to some constant c. So if I write plus c here, that plus c is actually going to go the other side of our equation. So we happen to know that our f of v comma x is equal to, well, here's our f of vx right there. It's x squared v squared over 2 plus g of x. And g of x is actually, as we've just found, a negative 32 thirds x cubed. And this is all supposed to be equal to a constant c. So far, so good. Would love to have an initial condition. And luckily, I just wrote one down. Remember that at time 0, not time 0, but actually at time 0, then our chain length is 3. And perhaps the thing that might throw some people off, just thinking about the past here, what might throw people off is that is a function time. X is a function of time. And we don't have time in this formula. So how are we going to do that? Well, they actually give us the clue. Let's see. I have to find it here. I'm going to highlight it. Lucid coil. Supposed length weighs in that positive. Starting at time 0, the weight of the portion causes the chain to uncoil smoothly. Okay, so this sentence right here. Starting at time 0, okay, the weight of the overhanging portion causes the chain to move. So I'm going to assume that at time 0 specifically, the velocity is nothing. And that means that the velocity, I'll write this in black here, when the length of the chain, now remember velocity is a function of x, okay, the velocity when the length of the chain is 3 is going to be 0. So that will imply that when x is 3, v is 0. And so I will go ahead and substitute those in. X equals 3, v equals 0. So that means that this piece goes to 0, minus 32 thirds. And remember, I'm pretending as though x is 3, so that's 27, must equal c. That's going to be 9 times 32, which gives me a negative 288 for c. So there we have it. Our differential equation has this as its solution. We were told to solve this explicitly for v. We will in a moment here. X cubed is equal to a negative 288. Solving it explicitly for v implies Let's see. Well, velocity is going to be positive no matter what. So when I take the square root here, and I should just write while I talk. When I take the square root of this, I will get plus or minus, honestly. But velocity, we know, is going to be positive when we do the mathematics here. So let me write this in. V squared is equal to 64 thirds. This will be x minus, oh God. I'll just write that as 2 times 288 for now. We'll worry about it in a moment. Divided by x squared. Is that right? I think so. And then let's see, anything else I need to do? Take the square root of both sides. Something I might do here, this number is actually divisible by 8. So let's see, 8 goes into 288 72 times? That's not right. 71 times. Okay, so it's 71 times 8. And so I have 8 times 2, which is 16. That's kind of useful. That's not right. Okay. So let's see. 8 goes into 240 30 times. And let's see, we're left with 48. So that's another 6. So that's going to be 36. 8 times 36. And something kind of nice about that number there is you see in a moment, this 64 thirds x minus twice 8, and I'll pull a 2 out of that 36 as well. Or maybe I'll pull a 4 out of there, actually. So that's going to be 64 times 9 over x squared. And now I can go ahead and say that implies that v is equal to the positive square root of 64 thirds x minus 64 times 9 over x squared. And you can actually pull a 64 out of that. So this is equal to 8 root x over 3 minus 9 over x squared. Okay, so that's our formula for part A. And then part B, determine the velocity when the chain leaves a platform. That's just asking what's the velocity when the length is 8. So what's the velocity when the length is 8? And you can actually just plug that in here. 8 square root of 8 thirds. This does not look like it's going to be anything pretty. So I will grab a calculator. Okay. And that is roughly 12.7. And I don't even know the units that I'm in. Let's see. I think it's feet and pounds. And it must be seconds. Feet, seconds, and pounds. Usually that's how it works. So I'll say feet per second.